Hello everyone. Good evening. I am Prithvi of Electronics and Communication Department, and my student is 224700491. And here is my continuous alternate assessment of probability and complex variables. And the topic is like I just have got a problem on the complex variables, complex differentiation, and it goes like prove that the function f of z is defined by basically f of z is equals to x cube into 1 plus iota minus y cube into 1 minus iota divided by x square plus y square, where z is not equals to 0. Basically, uh, yes, when it is not 0, the whole f of z is 0. Sorry. When z is not equals to 0, we have got this function. When z is 0, the function is also 0. And we have got three cases here to check its continuity and whether it satisfies Cauchy-Riemann equations at the origin, and the first order differentiation with the limit as 0 does not exist. We need to check all these three. Let's go with one by one. So what I said is written here. The first thing, f of z is continuous at the origin. We need to check that, and the Cauchy-Riemann equations are satisfied at the origin, where x is equals to 0, y equals to 0, and that is what origin is. That's the second condition. It's not a condition, it's a thing which we need to prove. And first order differentiation with limit as 0 does not exist. We need to prove all these three. And the first one is to check the condition. So let us assume t is equals to iota. So the function becomes, so basically we need to break the functional parts by um, the real part is separated and the imaginary part is need to be separated. So basically function f of z is equals to u, z is equals to u plus iv. U is nothing but the real part and v is nothing but the imaginary part. And that is how we separate the variables. And u is a function of x of y, where it is a real part, and v is a function of x of y. It contains a imaginary part side. So let's begin. So when the function f of 0 is 0, u of 0 comma 0 is also 0. So the both functions are 0 at the 0 comma 0. So basically we are interpreting the function correctly. So the first step to prove continuity at the origin. By using the polar coordinates, where x is equals to r cos theta, y is equals to r sin theta, we just need to put the value of x is equals to r cos theta and y is equals to r sin theta in the equations. We have which equation? The first one, f of z is equals to x cube 1 plus iota minus y cube 1 minus iota by x square plus y square. We need to put x is equals to r cos theta, y is equals to r sin theta in the equation, and we'll be getting the sum of x square plus y square is equals to r square actually. Yes, we'll put that, and the same thing. Take r square out, we'll be cancelling it out. Sorry, take r cube out, and the r square gets cancelled. And when the r tends to 0, f of z also tends to 0. And regardless of theta. So function f of z tends to 0 in the function f of 0. I mean f of z also tends to 0 when the z is equal to 0. So the second condition is proved. The functions are continue at the origin and checking the Cauchy-Riemann equations at the origin. Beginning with we are going to start with the partial derivatives of real sum by using the limits u of x at the 0 comma 0 by substituting the limits u of h comma 0 minus u of 0 comma 0 all divided by h, and limits h tends to 0. When does the h tend to 0? Because we are checking at the origin. The Cauchy-Riemann equations are being checked at the origin, so they tend to 0. H cube minus 0 by h square minus 0 by h, and the final one we got here is 1. And when you compute for imaginary part, which also tends to 0, and the final one we got here is 1. So they both are same. We got them in same. Now, when we take here, you have checked for x values and y values in the V. Now we'll be checking for y values and x values. The thing is ux is checked here and vy is checked here. Now uy is checked here and vx is being checked here. So we have got -1 here while checking for uy, where the y limits of u has h and other are origin. We have got it as -1, and vx, obviously the h value is h and others are origin like 0 comma 0, and by calculating that they both are not same, so that gives us uy is equals to -1 and vx is 1. So they both are not same. The other is a negotiation of the before one. So the both Cauchy's Riemann equations hold at 0 comma 0, and that is satisfied here. And that is what basically the Cauchy's Riemann equation states, like ux is equals to vy and uy is a negotiation of v of x, like the minus v of x. And that is what we found here. And the final one is to we need to just differentiate that the initial function, this function x cube into 1 plus iota minus y cube into 1 minus iota by x square plus y square. This needs to be differentiated, and the value which we need to substitute here is 0. On differentiating that, like by using the limits, z tends to 0. You got it here, yes? Yes. When the limit, when it tries approaching the real axis, z equals to x and y equals to 0, um, f of x is equals to x cube into 1 plus iota by x square, which we got it as 1 plus iota. Try along the imaginary axis. It's basically making the real part as 0 and trying the different limits for the imaginary part, minus y cube into 1 minus iota by y square. And we got the same as 1 plus iota. So basically along the y-axis, we got it as 1 plus iota. Along the x-axis, we got the same 1 plus iota. So z is equals to x plus I into x. Basically y is equals to x. Then just substitute them. So by using the rationalization, we rationalize them. So along real axis, it's 1 plus I. Along z is 1 plus iota by 2. Therefore, the limit does not exist. F is not differentiable at 0. The final conclusion is f of z is continuous at z equals to 0, and the Cauchy remain at z equals to 0. It holds. And the final one is f dash of 0 does not exist. And that's that. Thank you. Thank you for your attention. That is end of the video presentation.